Okay, this is a really interesting question. I'm actually going to have fun doing this one. What we've got is a nuclear power plant. Okay, so here's our nuclear power plant, and of course, you know, we've got the cooling towers beside our plant, and our plant is producing electricity. Now, this nuclear power plant produces 6 gigawatts of electricity. Now, gigawatts means billion, so it's producing 6 times 10 to the power of 9 watts of power. Now, what's another unit for watts? That's another way of saying joules per second. Now, the question that I'm going to ask is, if this nuclear power plant obviously is using nuclear material, if it's 100% efficient, what, or I should say how much, matter is converted to energy in 1 year? So, how much nuclear material consumed in 1 year? The way we're going to figure that out is, first of all, since we know how much energy is consumed per second, 6 billion, all we need to figure out now is how many seconds in a year. In order to figure that out, we're going to go 60 seconds per minute multiplied by 60 minutes per hour multiplied by 24 hours per day multiplied by 365 days per year. And if you'll notice, watch what happens. Minutes cancels minutes, hours cancels hour, days cancels days, and we're left with seconds per year. And now if we get our trusty RPN calculator, of course 60 times 60 is 3600. So we'll just go 3600, enter 24 times, 365 times, and we're left with a very large number. Basically, I think that's going to equal, hope I did that right, 31.5 times 10 to the power of 6. So 31 million seconds is the number of seconds per year. Now, let's store that. Let me just double check that calculation. 3624 times 365 times. Yeah, it's right. Okay, now that we know that, how many seconds per year, all we need to do now is we need to multiply these two numbers together. 6 times 10 to the power of 9 joules per second multiplied by 31.5 seconds per year. And of course, the seconds cancel out. This is times 10 to the power of 6. And we're going to get 6e9 times, and we're going to get an answer of 1.9, say, times 10 to the power of 17 joules. Okay, so that's how much energy is produced per year. Question is now, how much mass does that translate into? Well, in order to do that, we're going to have to get the equation E equals mc squared, probably the most famous physics equation. And we're going to solve for mass, because this, of course, is the energy. We've already calculated that. But in order to solve for mass, we rearrange the equation with a little bit of algebra, and we say m is equal to E divided by c squared. And so if we plug our values in, we're going to get 3 times 10 to the power of 8 squared, of course. And we're going to get 3e8 squared divided by. And voila, we get an answer of 2.1 kilograms. Holy smokes, could you imagine that? An entire year's worth of energy from a large nuclear power plant producing 6 billion watts of power. An entire year worth is equivalent to 2 kilograms of mass. Now, of course, please understand this is assuming 100% conversion from mass to energy, but nonetheless, that's pretty significant. That's a lot of energy from such a small amount of mass. Now, the second part of this question, which I really find interesting, is how much money does that translate into? So if you think of the 2 kilos as the raw resource and the final product as this much energy, electrical energy, how much money does that much electricity correspond to? Well, in order to calculate that, we're going to have to figure out what the price of electricity is. The price of electricity is approximately, depends on where you live, but I'm going to give a pretty rough estimate here. I'm going to say about 9 cents per kilowatt hour. Now, electricity is actually measured in pennies per kilowatt hour. That's how electrical utilities actually charge you for it. But what is a kilowatt hour? Well, we all know that our old incandescent light bulbs are 60 watts, right? The newer compact fluorescents are about 13 watts. But a kilowatt is 1,000 watts. That's kilo. Okay? So if you have an appliance or whatever it is, maybe you have 10 light bulbs each at 100 watts. Well, if you had 10 of them running for an hour, that would be 1 kilowatt hour. So you multiply this by 1 hour, and that's how much energy it is. Well, let's figure out how much energy that is in joules. In order to figure this out, we're going to have to convert the watts to joules per second, like we did before. And we're going to have to change the hour into the number of seconds. Now, we've done that already way up here. We actually did it. It's actually 60 times 60, which is 3,600. So let's replace this with 3,600 seconds per hour. And, of course, the seconds cancel out. And we're left with joules per hour. And the answer to that is 3.6 times 10 to the power of 6 joules. Okay, so there's 3 decimal places here and 3 decimal places there, right? So that's 3.6 million joules. In other words, I can also write this as 3.6 megajoules. So 3.6 megajoules costs how much money? 9 cents. Wow, that's a pretty good price. Less than a dime for over 3.5 million joules of energy. Question now is, hey, how much money did that power plant produce in terms of electricity? Well, in order to do that, we need to figure out what 1.9 times 10 to the power of 17, how many times does 3.6 go into that? So 1.9 times 10 to the power of 17 joules divided by 3.6 times 10 to the power of 6 joules. And you know what that'll give us? That'll give us how many 9 cents we have. So if we simply, multiply this number by 9 cents, so instead of equals here, let's go multiplied by 9 cents. And let's not make it cents, let's make it dollars. Dollars is $0.09 is 9 cents. Let's actually find out how much this is. I'm really curious now. 1.9 EE17, enter. 3.6 EE6 divided by 0.09 times. And the answer we're going to get, hold on to your horses here, is, are you ready for it? 4.75 times 10 to the power of 9. And that's not cents. That's, you guessed it, dollars. In other words, $4.75 billion. And how much is almost $5 billion? Where did this almost $5 billion come from? No, come on, you're kidding me. Yeah, that's right. It came from 2 kilograms of mass. And how far out is that? Enjoy. Hope you enjoyed this problem. See you next time.